Hello and welcome to the CCNP Routing and Switching course offered by SimplyLearn. The last lesson focused on redistribution. This lesson will focus on IPv6 routing. Let us begin with the objectives of the lesson in the next slide. By the end of this lesson, you will be able to identify the advantages of IPv6, configure various IPv6 address types, configure stateful DHCP v6 and SLAAC, describe the IPv6 routing protocol, including RIP-NG, EIGRP for IPv6, and OSPF v3. Describe multi-protocol border gateway protocol. Configure access lists in IPv6. Let us start with a discussion of the advantages of IPv6 over IPv4. IPv6 provides 3.4 times 10 to the 38th power addresses versus the 4.3 billion addresses provided by IPv4. The increase in the number of addresses is the biggest benefit of IPv6. In fact, in IPv6, there are multiple addresses per interface. The blocks of IPv6 addresses are allocated to make aggregation easier than IPv4. There is no need for Network Address Translation, NAT, or Protocol Address Translation, PAT. There are other advantages of IPv6. IPsec security and mobility support is inherent in IPv6. Internet Control Message Protocol version 6, ICMP-v6 messages, are sent in IPv6 packets. In IPv4, ICMP-v4 is a separate protocol. IPv6 performs MTU discovery. In combination with ICMP-v6, IPv6 determines the appropriate MTU size. It retransmits the packet with a progressively smaller MTU until it arrives at the destination. Flow labels identify packets that are part of the same TCP or UDP connection. Therefore, multi-layer switches and routers can process traffic on a per-flow basis. This is more efficient than processing packet by packet. Since IPv4 is running out of addresses, a move to IPv6 is imminent. Cisco iOS release 12.2t and later, with the appropriate feature set, is IPv6 ready. Visit the website given on the slide to test if your equipment is IPv6 ready. Let us learn about IPv6 addresses.